So last time we were discussing uh, basic principles of green chemistry, right? So as as we have already understood that green chemistry is a clean chemistry, and it is being proposed to have new synthetic route to manufacture various products. Various products. I would like to repeat the list. The products include plastics, rubber, means all polymers, then pesticides, insecticides, then major domain is medicines, means all pharmaceuticals, foodstuffs, so on and so forth. These products which are being prepared from petroleum products, means petrochemicals, which are depleting and which are polluting and hazardous also. So we need to replace them, okay, because we are facing several troubles, environmental issues, health issues, etc., etc. So we have to replace all such hazardous route by the clean and safe route. That is what green chemistry. Okay, and accordingly, 12 principles are proposed. So for every chemical industry has to follow this 12 principle before manufacturing any product. Okay. Okay. So last time uh, we discussed this atom economy principle with respect to various chemical reactions, right? So we understood what is atom economy. This is what the formula for that. Then we understood actual how to calculate atom economy by taking example of preparation of malic anhydride from oxidation of benzene, then oxidation of butene and oxidation of butane. These are three starting compounds which are petrochemicals, and they are converted into maleic anhydride. So maleic anhydride is actually industrially imported ingredient, or we can say intermediate, okay, which is converted into final finished product, which may be polymer or any medicine, etc. etc. Okay, so we calculated atom economy for the first reaction, oxidation of benzene, then oxidation of butene and oxidation of butane. And then we realized the atom economy obtained from the second route, that is from butene, was maximum, okay, as compared to that of benzene or butane. So we concluded that this is what the best possible route for manufacturing malate anhydride, because atom economy is higher. Most of the atoms which are present in a butene, they are converted into final product, that is malate anhydride. So that is what atom economy is. So we utilize atoms economically in second route. Okay, that is what the best route. Now we will take few more examples to calculate atom economy and to realize its significance. Okay, so this is what we have already done. Okay, and we calculated molecular weights and atom economy. So this we already completed. Okay, so let us have few more examples. Okay, so next example would be, so I will write reaction and let us see how to calculate atom economy. Uh, so this is typical reaction, Friedel-Crafts reaction, okay? Alkylation of aromatic compound. So in this case, so starting compound, say benzene. So as I told you, this is alkylation of aromatic compound. And at aromatic compound, you have already studied a lot. So this is first or basic aromatic compound called as a benzene. Okay. So in this case, we will add alkyl group to this benzene ring. So that is what alkylation of benzene. That is alkylation of aromatic compound, and we will calculate its atom economy. So benzene plus we should take alkyl halide. Say for example, CH3Cl. Okay. Then in presence of aluminum chloride, LCl3. When we heat them together, what we have is there is replacement of one of the hydrogens of benzene by this methyl group. Okay, and we get alkyl group or methyl group added on benzene ring. So what I should do is, so benzene structure remains intact, no change in bond position, only change is one of the hydrogen atoms, okay, of benzene ring that is converted into, or that is replaced by methyl group of methyl chloride. Okay, so this is what the product. This is called as a toluene, or we can say uh, methyl benzene or benzomethane. Okay, it's commonly called as a toluene. This is also industrially important solvent. Okay. But this is not the only product. Something we have already added, which we cannot see in the product. What is that? Chlorine. Chlorine we have added. We have added aluminum chloride, but we cannot see in toluene. Okay, we cannot see them in toluene. There is no aluminum. There is no chlorine. So there must be byproduct. So I should write byproduct. So what is the possible byproduct? This hydrogen, which is replaced by methyl group, will combine with chlorine. Okay, and we will get hydrochloric acid, HCl, as a byproduct. Now, in this case, aluminum chloride is a catalyst. So it will not take part in actual chemical conversion or reaction. Its role is to accelerate, initiate and accelerate this conversion. Benzene to toluene conversion is being accelerated by aluminum chloride after heating them together. Okay, so this is what the reaction, typical Friedel-Crafts reaction, means alkylation of benzene. So let us calculate its atom economy. Now, if you look at the structure of the reaction, you will find there is main product. Main product is toluene, okay, and also the byproduct. So definitely, we can say atom economy is not 100%. We have wasted atoms. Okay, so let us calculate the efficiency of this reaction. So how to calculate efficiency? That is with respect to at percentage atom economy. Okay. So what is the formula? Percentage atom economy, total molecular weight. Okay. Or molecular weight of product. Okay. Only product, not byproduct. Divided by total total molecular weight. Total molecular weight of all reactants. Right? All reactants. Reactant is like into 100. Okay. So molecular weight of product means molecular weight of toluene divided by total molecular weight of all reactants. All reactant means what? Benzene plus methyl chloride. Benzene is the first one and second one is methyl chloride, and aluminum chloride should not be considered. It is catalyst. So this is the important thing you must know while calculating atom economy. Okay, so we did not consider byproduct also. We considered reactants, these two reactants, and final product, major product or main product, and we did not consider byproduct as well as catalyst. Okay. Now let us calculate molecular weight of the product. So product is toluene. So toluene means, I will write over here, benzomethane. So just calculate carbon. Now to calculate molecular weight, we must know correct molecular formula. So we have the structure. So let us calculate molecular formula. So just count carbon. We have 6 carbon in the ring, okay, and one more in methyl group. So altogether 7 carbons. Okay. Then hydrogen. Now since there is no oxygen, okay, only carbon and hydrogen can be calculated. So let us calculate hydrogen. So here we have 3, okay, they are clearly displayed, but when you look at the ring, hydrogen atoms are not displayed, they are hidden. Okay, so how to find out hydrogen? Just by counting bonds. So this is ring structure. If you look at this or here at toluene structure, we can calculate hydrogen very easily. Here we have pi bond clearly shown. So here at the first position, there is no hydrogen. Why? Because carbon has valency 4 and all 4 valencies are occupied by bonds only. 1, 2, 3, 4. So here there is no hydrogen. Now at this carbon, we have 1, 2 and 3 bonds. So fourth must be hydrogen. So here we have one hydrogen. Then at this position, 1, 2, 3 means one more hydrogen. Here also 1, 2, 3. Here we have one hydrogen. Again, we have 3 valencies occupied by the bonds. So fourth one must be hydrogen. Here it is again same situation. 3 bonds means fourth must be hydrogen. So how many hydrogens remain? 1, 2, 3, 4, 5. Okay. Is 5 hydrogens, and here there is no hydrogen, but 3 hydrogens. Okay, with alkyl group. So 5 plus 3 means 8. So I must write 8. Okay. So this is what the product. So just calculate. So 7 into 12. Okay. 12 into 7. One carbon is 12 into 7 plus one hydrogen is 1 into how many hydrogens are there? 8. Okay. So 84 plus 8 means 92. So molecular weight is 92. Okay. Molecular weight of product, main product or toluene is 92. Now let us calculate molecular weight of benzene and methyl chloride. Now if you look at the benzene molecule, you can easily guess carbon, 6 carbon. Okay, C6. And hydrogen we already know how to calculate. Okay. At every corner we have one hydrogen atom. Okay, because valence is 3. At every corner, valence is 3. So fourth must be hydrogen. Okay, so we have 6 corners, so 6 hydrogen. C6H6. So here again we can calculate molecular weight like there are carbon, one carbon atom is 12. We have 6 such carbons plus one hydrogen atom is 1. We have 6 such hydrogen. So it becomes 12, 6, 72 plus 6 is 70, 78. Right? Okay. Now methyl chloride. So it is a straightforward molecular formula. So carbon I should write 12 plus hydrogen is 3 plus chlorine is 35.5. Okay. So we have molecular weight of methyl chloride, we have molecular weight of benzene, molecular weight of toluene. Just substitute in the formula. So product is 12 it is 92 molecular weight upon molecular weight of reactants. So benzene is 78 plus, so this becomes 12 plus 3 plus 35.5. So it becomes 50.5. Okay, 50.5 methyl chloride. Okay, so product is toluene, molecular weight 92. Then 78 is benzene, reactant, first reactant, and second reactant is methyl chloride. So it is 50.5 molecular weight into 100. So it becomes 71.59. 71.59 is approximately 72%. So comparatively, we can say good atom economy. Okay, 71.59. So this is the way you should calculate atom economy. So what is the basic requirement or first requirement? You should be able to write balanced chemical reaction. This is very basic requirement. The reaction must be balanced with proper molecular, proper structural formula. Okay, balanced chemical reaction with proper structural formula. You should not miss single atom or any single bond. Okay, so once you have balanced chemical reaction, your job is very easy. You just have to calculate molecular weight of product and molecular weight of all reactants and not catalyst, not solvent. Okay, this is what the only concept you should keep in your mind. Okay, so I hope you understood what I want to convey. If you have any doubt, you can ask anytime or you can post on group. Okay. So we will take another example. I am erasing this. So another example, this is an interesting example we can say. Uh, Let me write propene. Propene means 3 carbon. Okay, let me tell you how to write the structure. I will erase out quickly. Okay, so what I want is propene. So I want hydrogenation of propene. Problem with the pen. So starting compound is propene. Okay. So after hydrogenation means I must add hydrogen atoms. So I will get some product. Okay. So I guess it is propane. Okay. So starting compound is propane. So prop means 3 carbon. 1, 2, 3. Okay. In. In means what? Alkene means 1 double bond. So these two positions are equivalent. So you can write double bond over here or at this position, no issue. Okay. So this is backbone or skeleton of propene. Now remaining is what? Hydrogen substitution. Okay. So here carbon is attached to 2 bonds. So 2 valencies are occupied. So total valence is 4. So 4 minus 2 is 2. So here must be 2 hydrogen. Okay. Then here this middle carbon, it is surrounded by 3 bonds. 1, 2, 3. So 1 valency will be occupied by hydrogen. So here must be CH group. Okay, CH group. Then this carbon, here we have one bond. So 3 minus 1 means, 4 minus 1 means 3. So 3 hydrogen atoms are directly added. So 3 plus 1 becomes 4. So valency becomes 4. So this is what propene, when I add hydrogen, okay, in places of nickel catalyst. Nickel, heat under pressure. Okay, you see, I took propane, I passed hydrogen gas into it in presence of nickel catalyst under pressure. Okay, so what I have is a propane. So if you observe the structure of the reactant, in is converted into N. Okay. So so in actual reaction, what is happening is this hydrogen molecule gets added over the double bond. So here we will get two hydrogen atoms added by utilizing one of the pi bond. Okay. So number of carbon atoms remains same, 1, 2, 3. Okay. And previously we have one pi bond over here. So that pi bond is replaced, or this pi bond is substituted by two hydrogen atoms, means one hydrogen molecule. Okay. So we will get here H3 will remain as it is. Here CH was there, one hydrogen added. So here we get CH2, one hydrogen atom added. Here it was CH2 previously, one hydrogen atom added means it becomes CH3. Okay. Now, if you compare the structure of propene and propane, this is propene and this is propane. If you compare the structure, so the only difference is this pi bond. This pi bond is replaced by sigma bond by adding two hydrogen atoms. One at this position and another at terminal position. That is the only difference. Removal of pi bond, addition of two hydrogen atom across the double bond. Okay. So this is what actual reaction. Now we are interested in what? Calculation of atom economy. Okay. Now if you look at the reaction without even calculation, you can judge atom economy. Okay. Just listen carefully what I'm saying. By looking at the reaction, okay, this is balanced reaction. You can calculate or you can guess atom economy without even calculation. How? Very simple. If you look at the product side, there is no byproduct. Means all atoms which are present in reactant. Means what? Reactant is propene and hydrogen. These two are reactants. Okay. So all carbon, hydrogen atoms, they are present in both propene and hydrogen. They are converted into desired product, that is propane. So there is no loss of carbon and hydrogen. So no loss of carbon and hydrogen is what? Atom economy is 100%. Atom economy or percentage, atom economy is 100%. Okay. So now let us, but in examination you have to apply the formula. Okay, by writing balance reaction and then calculating molecular weights and substituting in the formula, you need to calculate atom economy. So we will calculate atom economy, percentage atom economy. Okay, so molecular weight of product upon molecular weight of all reactants into 100. Okay, so here what is the molecular weight of product means what? I should write molecular weight of propane, right? Product means what? Propane. Sorry. Okay. Uh, Propane. Molecular weight of propane divided by molecular propane is what product. Molecular weight of product. So molecular weight of reactants. Reactant कौन कौन है? Propene. Propene एक आयन कौन है? Hydrogen. Hydrogen molecule into 100. Okay. So this is what the formula. So molecular weight of propane. म्हणजे ह्या molecule से molecular weight काढायचा आहे. कसं काढतं? By first calculating number of carbon and hydrogen. Means just writing molecular formula. Molecular formula कसा काढतात? C. Carbon किती आहे? 3. C3. Hydrogen 3. 3 6 plus 2. Means how much? 8. C3H8. Correct. You're right. C3H8. So C3 means what? One carbon is 12 into 3 carbon. We have total 3 carbon plus one hydrogen into 8. How much it is? किती आले बघा 12 × 36 आणि 8 44 राईट molecular weight 44 okay so that is what the numerator molecular weight of propane 44 divided by molecular weight of propene म्हणजे इकडे आला पाहिजे okay so here what is the formula कार्बन किती आहे 3 कार्बन 3 हायड्रोजन 3 plus 4 plus 2 किती आले 3 आणि 1 4 2 6 H6 म्हणजे किती 12 is 36 plus 6 बरोबर 12 1 कार्बन इज 12 असे आपल्याकडे 3 आहे एक हायड्रोजन म्हणजे 1 असे आपल्याकडे 6 म्हणजे किती आले 36 आणि 6 मीन्स 42 सो प्रोपेन मॉलिक्युलर वेट 42 प्लस हायड्रोजन मॉलिक्युलर वेट हायड्रोजन मॉलिक्युलर वेट काय सोपं आहे 1 हायड्रोजन इज 1 ओके 1 हायड्रोजन इज 1 असे आपल्याकडे किती हायड्रोजन आहे 2 म्हणजे मॉलिक्युलर वेट 2 okay molecular weight 2 so this is what the molecular weight into 100 okay into 100 so molecular weight of product means molecular weight of propane divided by molecular weight of all reactants means propene plus hydrogen molecule okay into 100 so we will get 44 upon 42 plus 2 is 44 into 100 so this get cancelled we get 100% economy okay so whatever you look at the reaction there is no byproduct right so that is what atom economy must be 100% and same thing we have over here 100% so it is proved that this is what the root with 100% atom economy okay so this is what the significance of this principle atom economic principle now let us move to the next reaction I will erase out everything okay. So next reaction is again the Friedel-Crafts kind of reaction so starting compound is same starting compound is benzene okay but here reactant is acyl chloride it is acyl chloride okay CH3COCl acyl chloride so what we will get is this benzene ring remains intact no change only change is one of the hydrogen atoms okay will be replaced by COCH3 group okay and we will get byproduct is must be this hydrogen atom is replaced that hydrogen atom and this chlorine atom they will combine together and they will produce HCl okay so this is benzene this is actually acetyl chloride I will write the name acetyl chloride after heating in presence of catalyst AlCl3 right AlCl3 so what we have is this compound this is called as a acetophenol this is again important industry important now this is ketone it is ketone benzene C double bond OCH3 if you look at the structure this is actually acetone okay acetophenol so this is what the reaction given to you and if I ask you to calculate atom economy okay now if you look at the structure since there is a byproduct formation definitely the atom economy is not 100% okay let us calculate so to calculate atom economy we must know the molecular weights. So to calculate molecular weight, we must know molecular formula. So in case of benzene, it is C6H6. Okay. Now C6 means one carbon is 12 into 6 plus one hydrogen is 1 into 6 hydrogen. Okay. So 72 plus 6. So it becomes 78. Okay. Now acetyl chloride. So here we have a molecular formula ready. Let us calculate its molecular weight. So if you look at the structure, one carbon means 12 into 1 plus 3 hydrogen. One hydrogen is 1 into 3. Okay. So, but we have one more hydrogen over here. So that we should add over here 12. 12 carbon. Okay, one carbon is 12. Plus one oxygen. One oxygen atom is 16. Plus one chlorine atom is 35.5. Okay, this is the way you can do it. So it becomes 78.5. If you add them together, okay, it is 78.5. You must be careful while calculating this. You see, we have actually two carbon atoms. You can add them together or separately. So I added separately. So I took one carbon. So one carbon is 12. So 12 into 1. Okay. Then I look at hydrogen, three hydrogens. So one hydrogen is 1 into 3 hydrogen, means 1 into 3. Plus one carbon means 12. Plus one oxygen. One oxygen means 16 and one chlorine atom means 35.5. So when I add them together, I got 78.5. Now look at the acetophenone. Here it is very interesting and very important to find out correct molecular formula and then molecular weight. Okay. So first count carbon. So we have 6 carbon atoms with the ring. 6 carbon atoms. This is seventh one and this is 8. So I must write C8. Okay, 6 carbon atoms with the ring. This is 7 and this is 8. Okay, then hydrogen. Hydrogen 1, 2, 3, 4, 5. 5 with the ring. Okay, here there is no hydrogen. Okay, that hydrogen is represented. So 5 hydrogen plus 3 means C8H8. Okay, hydrogen also 8. 5 plus 3 hydrogen, 8 hydrogen. Oxygen atoms only one, so O. Okay, you see, but once again, carbon 6 carbon of benzene plus this carbon 7 and this is 8. C8 hydrogen 5 on the benzene ring and 3 means 8. So this is C8H8O is a molecular formula or acetophenone. Now 8 carbon means one carbon is 12. We have 8 such carbon. So 12 into 8. Okay, 96 plus 8 hydrogen means one hydrogen is 1 into 8, right? Plus one oxygen is 16. We have one such atom. So altogether it becomes, if you calculate, it becomes 120, 120. Molecular weight of acetophenone or molecular weight of product. So percentage atom economy is equal to molecular weight of product. Product means what? Acetophenone, AP, acetophenone, divided by molecular weight of all reactants. Molecular, sorry, molecular weight of reactant means molecular weight of benzene plus molecular weight of acetyl chloride into 100. This is equal to 100. So If molecular weight of acetophenone is 120 divided by molecular weight of benzene is 78 plus molecular weight of acetyl chloride is 78.5 into 100 into 100, so that becomes 76.68%. 76.68%. So comparatively good atom economy. So this is acceptable route. Okay, for preparation of acetophenone. Okay, so this is the way you should do it. You have to be very careful while writing molecular formula and other stuffs. Okay, so let us have another reaction. I will erase this out. Okay. So I have methyl amine, CH3 NH3, methyl amine plus COCl. This is actually phosgene, COCl2. And when they heat them together, we get methyl isocyanate. The hazardous chemical actually. So its structure is very interesting. CH3 ring to nitrogen, double bond C, double bond O. This is called as a methyl isocyanate. Methyl isocyanate. Okay. This is methyl amine. And this is carbonyl chloride, or commonly called as phosgene methyl isocyanates. So now reaction is straightforward. So atomic economy also can be easily calculated. So here you just count carbon 1, hydrogen 3 plus 2 is 5 plus nitrogen only 1. Here carbon, oxygen, Cl2 is straightforward reaction, no problem. Here just count carbon 1 and this second, so C2, hydrogen 3, nitrogen 1 and oxygen 1. C2, H3 and O. Okay. So this now molecular formulas are available. Just calculate atom molecular weight. So methyl amine, carbon is 12. So 12 into 1 plus 5 hydrogen is 1 into 5 plus 1 into 1 nitrogen is 14. So altogether it becomes 12 plus 5, it will be 17, 37 plus 4 means, sorry, 31, 27%, so 31. Right? So this is methylamine molecular weight. Phosgene, phosgene we have one carbon atom. So one carbon atom is 1 into 12 into 1 carbon plus 16 into 1 oxygen atom. Okay. Plus I have 2 chlorine, means 1 chlorine is 35.5 into 2. So altogether it becomes 99. Okay, oxygen is 99. If you add them together, you see, 1 carbon is 12 into 1, 1 oxygen is 16 into 1, 1 sorry 2 chlorine, 1 chlorine is 35.5. I have 2 chlorine, so 2 into 35.5. So altogether it becomes 99. Now this is what a methyl isocyanate. So I have 2 carbon, 12 into 2 plus 3 hydrogen, 1 into 3 plus 1 nitrogen is 1 into 14 plus 1 oxygen is 1 into 61. Okay, so altogether it is 57. 57. Okay, so we have got all molecular weights ready. Only thing is to substitute these molecular weights in the formula. So percentage atom economy is equal to molecular weight of product, means methyl isocyanate divided by molecular weights of all reactants, means molecular weight of methyl amine plus molecular weight of this compound. Okay. Carbonyl chloride, Cc, I will write into 100. Okay. So this is what the formula. So what we have is molecular weight of methyl isocyanate is 57. Okay, this is 57. Then molecular weight of methyl amine is 31. I write 31 over here into molecular weight of uh, carbonyl chloride or phosgene 99. 99 into 100. So it is just 43 43.80 43.85%. So this is less than 50% yield or atom economy. So we can say this is not acceptable good. Okay. Also, if you look at the reactant side, here we have got methylamine and phosgene, which are also hazardous in nature. Okay. So, so now see, if you look at the reaction, actual reaction we did not balance out. Here there are two HCl molecule removed. So the that is what a big loss. Two HCl molecule is a big loss. Actually, uh, while balancing out the reaction, we did not consider two HCl molecules, right? So actually two HCl molecules are there. That is what yield is just 43.85. Because this both the chlorine atoms which are present in the reactor, they are not there in the product. Okay, there is no chlorine atom in the product, but chlorine atom is there in the byproduct. That is why atom economy failed out to 43%. Okay, so this is what the significance of this method, atom economy calculation method. Okay, so today we will stop here. If you have any query in your mind, you can ask me now. Okay, or you can put it on chat box. So maths lecture will be starting soon.
Hello. काय विषयाचं काय म्हणताय बरेच दिवसांनी दिसलं तुम्ही कसे आहात